Hi, thanks for joining us today. We're going to continue our discussion of Lesson 5-4 on antidifferentiation or integration. So it just means finding the antiderivatives. We're going to be using the rules in the last lesson, which I still have right here. I'm going to be going a little faster. If you need me to slow down, I don't know, slow down the playback speed. Really, if you aren't understanding everything perfectly, come in for help. Come talk to me. Refer back to this chart. That's all we're doing. I'll talk about it as we go through it. I'm not trying to go through the problems too quickly, but if you need help, just let me know. So, we want to anti-differentiate x cubed. So we're going to follow the power rule. The power rule says take the x, add 1 to the power, 1 plus 3 is 4. Usually around this time this year, I say if you can add 1 to any number, you're good to go. Divide by the new power. Don't forget the plus c. You're done. You just did your first integral. All right, constant rule. This is just some constant. Whose derivative would that be? Well, it would just be 2x. If the slope was 2, it would look like a line, which is 2x plus c. The constant rule is harder to get used to. We did it we did it in the last video. Just adding an x plus c. If you need help, check the derivatives. Bring down the 4. 4 divided by 4 would go away. Subtract 1, back home. Derivative of 2x, 2. Derivative of c, 0. Okay, this one, we are basically just going to go straight through taking the integral. So what would be the antiderivative of t to the 4th? We would keep the t. We'd add 1 to the power. We would divide by the new power. Plus, just keep going. The antiderivative of 2, almost every student would say 2x when they're first getting started. That's wrong. That dt means with respect to t. So we differentiate with respect to t, so we're integrating with respect to t. So the integral of 2 is not 2x now, but 2t plus c. Again, check that this is the right antiderivative. 5 comes down, kills the 5, t to the 4th. Derivative of 2t with respect to t would just be 2. Derivative of c would be 0. Now, for number 6, almost every year when I do this in class, someone asks me, wait, I thought you said the sum rule was this. Which it is, and then the smarter students will say, but I don't understand. What happened to the other c? Shouldn't it be 2c because you integrated twice? Well, let's see how that plays out. So let's say we added a c each time. We'll call this c1. It was the first constant we got. And then I kept integrating, and I got t... Oh, that's why it doesn't look right. All right, sorry. There we go. And I got 2t plus c2. And to the careful observer, you would notice that these two things aren't the same, Mr. Leven. Well, first, for the purposes of a test, that would be acceptable. It sure takes a lot longer to write out than what we just did. So eventually, we want to get the confidence to just go straight through like we did with derivatives. Add 1c at the end. How are these the same? Well, let's try to force them to look the same. Let's put all the constants together at the end. Just rearranging based on, aesthetics. So this left-hand part's the same. It's this right-hand part that's different. But the main idea here is that this stuff is just one constant plus another constant. Constant plus constant equals constant, right? This is 5 and this is 7. So we're just going to group it and call it C. We're just going to add these two constants together and smush them together and call it capital C. That's really all we can do to explain it. If you did it this way, you just have two separate constants. I'm just combining all the constants into one big constant at the end. Takeaway lesson, if you don't like anything I just said. Whenever you're doing an indefinite integration, whenever you're doing an antiderivative, just add 1 plus c to the end. That's it. You don't have to worry about adding a c for each part. Just add a c when you are done doing the antiderivative. Next. So, put plus c when you integrate. Never when you differentiate. A lot of students get into this bad habit. They think the plus c is a, oh gosh, I always have to have it. Always have to have it. No, you don't. Oh, a big one. So again, we're not going to have 1, 2, 3 c's. We're just going to do it at the end. I'm just going to focus over here so I have space. So, keep the constant. That's what this constant rule means. The scalar multiple rule. Sorry. The scalar multiple rule says we can hold on to the constants at the end. So we hang on to the constant. We take y. We add 1 to the power. And we divide by the new power. It's that simple. You can keep everything in the top or not. It's right next to it. You keep the constant here. Just multiplying. We add 1 to the power. We divide by the new power. Integration of y with, spoilers, sorry. Of 1 with respect to y is y plus c. No need to differentiate. Sorry, no need to simplify. No need to simplify. If you took this derivative, you would get back here. You don't need to simplify this at all. If you did, if you wanted to simplify as you go, great. Now here's what I would like to call the first hard one. The first hard one. Just like with derivatives, you want to rewrite first. So I don't want to integrate 3 over x squared. What I do want to integrate, look how I keep the integral sign. If I anti-differentiate, my integral sign disappears. Once I start, if I'm just rewriting, I want to keep the antiderivative. If I'm just rewriting, I keep it called f with derivatives. If I'm just rewriting, I want to keep everything on the outside. Rewrite with a negative power. We don't know how to handle powers when they're in the bottom. No powers in the bottom. No power in bottom. In the denominator. How do we rewrite this? Well, we have to know the square root is a 1/2 power. So altogether, that's a negative 1/2 power dx. And now that I've rewritten it, now we can integrate. 3 x to the negative 1 divide by negative 1 minus x to the positive 1/2 negative 1/2 plus 1 negative 2 plus 1 divide by 1/2. plus c. Now, once you really start getting good, you probably won't write a big giant continued fraction. This is fine, but we generally don't like fractions in our fractions. So when you get good, you probably won't write that second part like this. You might write it as, oh, dividing by 1/2, that's the same as multiply by 2. Okay? These are the same answer. These are just slightly reorganized. If you want to keep the 3 with the x, that's fine. If you want to multiply by the reciprocal, that's fine. Just be careful. So a fully simplified answer here, just to go over it since we have time, would be something like this. That's much more likely to be an answer on a test, on a multiple choice part, than that. Now, besides having powers in the bottom, we also want to get in the habit of split when monomial in bottom. Now, maybe you're like, I don't know what a monomial is. Anytime there's one term in the bottom, I want to split it because there's no quotient rule for integration. There's no product rule for integration. You want to be careful and that you split this accurately. This means divide out first. So I'm going to write it out. I'm divide both. That means divide both. Not just divide one of them, divide both by x squared. And now no powers in the bottom. Power to the 1/2 minus power to the 2. X to the 1/2 minus 2. That's negative 3/2 power. No negative exponent, like that. Sorry, no exponents in the bottom, like that. Add 1 to the power. Negative 3/2 plus 1. Write it out in the margin if you have a hard time with this. I swear you'll start to get better at it. Everyone gets way better at adding fractions than they ever thought they could. Negative 1/2. Instead of dividing by negative 1/2, I'll multiply by the reciprocal of negative 1/2, which is negative 2. Add 1 to the power. Negative 2 plus 1 is negative 1. Instead of dividing by negative 1, I'll just make it times negative 1 plus c. Dividing by negative 1 is the same as multiplying by negative 1. So that's fine. So is this. Okay? I'd probably more likely to make that. Again, once you get good at it, you'll probably just go right to something like this. Okay? Don't worry about that right now. Just worry about getting an accurate answer. And again, in case I'm spooking you, that's fine. That's fine. That's fine. That's fine. That's fine. Do whatever is easiest for you. Add 1 by hand. Don't try to show off. You're going to mess up something, and then you'll really feel bad. And always, always, always remember the plus c. This video is going to get a little long. This is really important. Initial conditions. An initial condition will make it possible to solve for c. And here's how. So if someone gives me f prime equals x to the negative 3, this is the initial condition. Sorry, I should have highlighted that. So that's the initial condition here. and they tell me to find f of x. Not just anti-differentiate, but actually find f of x. So we're going to use our initial condition. So the first step, though, f of x would be the antiderivative of x to the negative 3 with respect to x. Does that make sense? Because f of x, f prime is the derivative of f. So it's sort of like I'm integrating both sides of the equation. And the antiderivative of f prime is just f. And then I just have to figure out what this side is. Okay? That's what's happening here. So f of x would be the antiderivative of that. So f of x, add 1 to the power, divide by the new power, plus c. Okay, so now f of 1 equals 3 over 2. So if f of 1 equals 3 over 2, let's try plugging in x equals 1. So when x equals 1, f of x equals 3 over 2. That's what that means, right? That's the idea. So f of 1 would equal 1 to the negative 2 power, divide by negative 2 plus c. F of 1 is 3 over 2. 1 to the negative 2 power is 1, negative 1/2 plus c. Add 1/2 to both sides, c equals 4/2, which is the same number as 2. So c equals 2. Putting this together with this, we find out that f of x must have been x to the negative 2 over negative 2 plus 2, the c value. Okay? That's fine. Make sense? You could try, I'm sorry, I didn't give recommendations earlier. For this specific one, if this is confusing, try 14. If you can't do 14, you're not up to it yet. This is specifically like 14 or 15. I assume this is one of the more stickier spots. This is like every problem up to 13, 14. All right, one last one. One last one for this video. So this means derivative, right? This means undue derivative, right? Undue derivative. Or antiderivative, right? That's the official name for it, antiderivative. So if we say, hey, take this expression, find its antiderivative, and then take the derivative again, what's really happening here is that those two cancel out, right? If I ask you to antiderivative, go back a step, and then take the derivative of that, this is just 5 root x minus 1 over x. Okay? You can do all that work in the world, or you can just realize that these two are opposite operations, inverse operations. Okay? And that's all I wanted to say for this video. So you should be able to do pages 92 until 93, 1 through 18. I would do all those problems, make sure you can do every single one, and then watch the next one. All right, that's it for now. Good luck on those problems. Have a lot of fun. Have a good night. Have a good day. Ta-ta for now.